This is a problem from the operation and supply chain management by the Russell and Taylor. It's the problem number 38 of supplement chapter 11. I'll post a link to this reference in the openeducator.com. This is a very interesting problem. So in the earlier videos, we have seen how to solve transshipment problem, also transportation problem. Now in a transshipment point problem where you have only one transshipment point, it's a little bit easier, but this one has two transshipment point in between. So parts are produced in these three different European cities, and then they go by ship to this seaport, and then from the seaport it goes to the inland port, and then finally they make it to the distribution center. So similarly, the demands in this distribution center drives all this original shipping here from the European cities. And of course, we have to check whether we have enough capacity for this. There is an intermodal capacity given and also the seaport capacity given. So we'll have to check all this number. So I'm going to show you step by step how to solve this problem. Let me move this thing away a little bit far. You can always go back to the video to read the problem. So first what I need to do is to find out the total production in these three European cities, or available container in this case, containers. So we're going to simply use sum of all the material they produce in these three European cities. So 495, and then we'll find the US the shipping port seaport capacity, and so basically sum of all the seaport capacity, which is this, and then the inland port capacity. We are setting this problem in a way so that we can use the Microsoft Excel solver function to solve this problem. And these are some initial steps to do that. So the inland port capacities are this. And then we have the demand, which drives everything. So here is the total demand. So we have total demand is only 420, and the seaport, so we'll be able to fulfill all the demand. We have enough seaport capacity, we have enough inland capacity, we also have enough supplies from these three European cities. So let's first do some more steps so that we can use that solver function in Excel. Now to do that, I think what I need to do first is to move this cost table. This is the cost given for shipping from these European cities to these three different places. I'm going to move this problem a little bit away like that, and then I'll move this cost too. Let's move it here, and then this cost table move aside here like that. And then the Excel will start with a 0 shipment for all of these and find the optimum number after doing all those long linear programming calculation behind the scene, and give us the so that going like this. Okay, so total item ship, now it will show 0, but after the manipulation by the Excel, it will have some numbers from this on top to these 4 different US shipping seaport. Copy down. Then we need also to have a shipped row here like this, sum of these 3, and then copy all this here. We're gonna do the Some of these different, we need the same sum of the stuff shipped to Ohio from these 4 shipping ports. Then we also need the demand. We'll be able to fulfill all the demands, so that will go in the constraint. However, we need to first do this, set up these rows or manipulation, I would say. Shipped sum of all of this going from Ohio to this 5 distribution center. Copy down like that. We also need the transshipment point, so we'll write transshipment constant point where nothing stays in these intermediate ports, where we have 4 seaports and 3 inland port, like that. So basically we say whatever shipped to Boston, which is this amount, minus this is the amount that goes out of Boston. Same thing, Savannah, shipped to Savannah, and then things get out of Savannah, this piece, equal to Mobile, Alabama, minus goes out from Mobile, Alabama, equal to Houston, Alabama, minus goes out of Houston, Alabama. Now the inland port, so whatever goes to the inland port to Ohio, minus whatever get out of Ohio, which is this piece. Probably easier way to do it, I don't know. This one, and then the last piece is going from North Carolina and then getting out of North Carolina is this piece. Then we also need the cost function, objective function. Now to do that, we haven't really calculated the cost cell yet. Let's do that calculation. So here I'm going to type the amount shipped from Antwerp to Boston times the shipping cost for that. I'll just simply copy these two like that. With this copy and paste, I would like to check the last cells if you have done it correctly or not. And then I'll just simply copy 3 of these right here. It should automatically get the job done. Yes. Oh, I gotta extend this one more for like this. Let me double click on the last cell. Looks like that's correct. Going from Houston to North Carolina times the cost of that. So I'm gonna do the same here. Basically the amount going from Ohio to Phoenix times this, and there's gonna be 5 of them. Oh, something didn't copy. Like that. I want to check the last cell. North Carolina to Memphis looks correct. So the cost function basically sum of all of these cost in these 3 different tables. I think I'm ready to, oops, didn't type the equal. I'm almost ready to go to the constant table. So this is all my cost. Now I'm going to optimize that. So we're going to go to solver, data, solver. I'm going to optimize this cost and then minimize the cost. And then this time Excel is going to manipulate or change 3 different tables. In the earlier version of transshipment model, we have only seen only two tables. This time we're going to change, Excel is going to change 3 different tables by optimizing the cost. Now we need to add some constraint now with the formula. Okay, there's something, there is an extra comma I hit which I didn't need. Okay, so the first constraint is We won't be able to ship everything that we produce because the demand is 420, but the total produce is 495. So that ship will be less than what we produce in there. So that's one constant. I need to add the second constant, which is the seaport capacity, which has more, but still we won't be able to ship everything because there is not much demand. So it's going to be a less than constraint, less than or equal to. Then add this will also be less than this. And then we'll add more constraint. We'll be able to fulfill all the demands. So I'll type that. And then the final constraint is all this will be 0. We're not going to ship anything extra to these intermodal places. So these are all constant we need. Now if you hit click OK, it will produce the results. However, if I hit OK, so let's say solve, it's already replaced all the numbers for me. Normally I like to copy a fresh data set, but which I forget here. So if you forget like that, what you can do is if you hit OK right now, it's going to replace all this number with the solution. So you can hit cancel again, and then let's say this is the clean data. I usually like to keep a raw data too, but it's a long problem. So I'll name this as a solution, and then hit the solver. Oops, not data analysis. So solver. Right now I'll hit this solve. So now I will hit OK. So this is the solution to that problem. So this is the cost is gonna take to do all this shipping. Now you can have multiple intermediate points. There's some restriction. I think this is a nice problem where you can get a better understanding of this transshipment problem.